In this video, we're going to look at questions 2 through 4 from the Unit 3 MCQ review, materials by Brian Passwater. Let's look at the very first one. It says that we're going to use the graph of the periodic function g below, where two full functions are shown. So the very first thing I would suggest is that we are going to identify, okay, we have straight line, it's going to increase and then decrease and come back, increase, decrease, and come back up. And so I can see that when I look here, that we do have cycles that are 7. So what is the period, which is also known as the period length? And so the period of this is a distance of 7. So that means that it's going to take 7 horizontal units for one cycle to occur before it repeats itself. Let's look at the next one. What is the value of 32? So we want to go horizontally and then figure out what is the output. So let's just think of this really quick. And there's a couple different ways, and I'll show you in number 4 how we can think about this, but we have 7. So let's go, we start here at 0, right? And then we start the cycle again at 7, and let's add 7 more, and we're at 14, and 7 more, right? And I just keep going here. Oh, all right, now 32. 32 is, so 28, 29, 30, 31, and 32. So this is the initial one, right? This is our 0. And so this is 0, 1, 2, 3, 4. So I'm going to go 4 over here. 0, 1, 2, 3, 4. And it should be an output value of 4. Correct answer is D. Let me move this up. And let's look now at number 4. Which of the following is decreasing? Now what would be really easy is if we had an option down below that we can see it's decreasing. Whenever we describe, as a reminder, increasing, decreasing, or constant, we're only ever going to use parentheses, and the values that we use to describe these intervals will always be in terms of x values. So I can see it's decreasing or going down from left to right between 4 and 6. I can see it's decreasing between 11 to 13. What I don't want to do is I don't want to continue to do 7 out, 7 out, 7 out, and then get all the way to these numbers. So is there an easier way? That would work, but is there an easier way? So the slow way of doing this would be to write, okay, we have 0 and then 7 and then 14 and 21, and we're just going to keep going. And so we can find out where does it fall in between here. So I know that it's the fourth one over, but which one? Is there a better way? So 7, let's just say 7, I don't know. 7K is going to represent, we could use any variable there, but it's going to represent the distance for one period. And I can know that it starts, this decreasing starts 4 past the initial part, and it ends 6 past. So I know that this should represent any one of the cycles here as we go to the right. Watch, if I put in this initial cycle, so if I put in 0, the initial cycle, I plug in 0, 7 times 0 is 7, and then I have 4, 7 times 0, 7 to 6. Yeah, from 4 to 6 it's decreasing. Let's do the second one. If I plug in 1, so here's your initial cycle, here's my first cycle. So if I plug in 1, 7 times 1 is 7, 7 plus 4 is 11, 7 times 1 is 7, 7 plus 6 is 13. Let's look over here. You're right, from 11 to 13, it's decreasing. So how is that going to help us? Well, we can use this, and let's think of numbers here. Like, okay, so I need to get around 70. So you could trial and error. You could try 8 and see if you've reached up, or 9, but I know 7 times 10 is 70. That's easy math. So if K is 10, 7 times 10 is 70, and then 70 plus 4 will be 74, and 7 times 10 is 70, and 70 plus 6 is 76, and that option is right here at C.